Building a computer can often be seen as a very complicated task, and for many users simply too complicated to undertake themselves. But in reality it's like riding a bike. Once you know how, you'll be surprised how easy it really can be. A computer is made up of many different components, most of which you can see here, all of which depend upon the number of choices and selections that you make. The first being what the computer will actually be used for when complete. For example, you could be building a computer for gaming, in which case you'll be wanting components like myself which are more gaming orientated and designed for speed. Or you could be using it for more normal tasks such as document editing, going on the internet, looking at cat videos, that sort of thing. In which case you won't be needing components which are as lightning fast as some of the ones you'll see here. So even though I'll be using components that are designed for gaming, the process of building a machine is actually exactly the same. It's just that a couple of the components will be slightly different, so no need to get worried while looking at this video and going, oh, he's using gaming parts. It doesn't make a difference. All the components go in the same places, and it's just the fact that the components themselves are slightly different. The best place to start when first deciding on the components you're going to use is with the motherboard. The motherboard is strangely comparable to the human skeleton and blood vessels. Each component of the computer is connected to the motherboard, so this means the motherboard actually determines what components you can use. So, with this motherboard I'm limited to only being able to use an Intel processor and DDR3 RAM, but we'll cover these sort of selections later on. Looking at the motherboard, we can see all the ports which we'll use to connect devices to the system. So starting at the top right, we have the 24-pin ATX power supply. Below that we have a USB 3 front panel header. Below that we then have 6 serial ATA data connections. At the very bottom we then have the front panel connections for things like the power and reset button and activity LED. To the left of that we then have 2 USB 2 headers. To the left of that we have some serial connections, but we don't need to talk about that here. And at the far left we then have the connection for the front panel audio. Up from that in the middle we then have the PCI X12 slot, which is for use with more legacy based cards. In the middle we have 2 PCI X1 slots for use with more modern cards such as sound cards. Up from that we have a PCI X16 slot. This is for use with graphics cards, which we'll move on to later on. Up from that in the middle we have the CPU socket. To the left of that we have the power supply for the CPU, and then on the right here we have the 2 DDR3 RAM slots. On the back we have 2 USB 2 ports, a PS2 mouse and keyboard port. We have VGA, DVI and HDMI out for the graphics card built in. You then have 4 USB 3 ports, a gigabit Ethernet port, and the output for the sound card on board. So if the motherboard is the skeleton and blood vessels, the CPU, or processor, is the brain of the computer. The CPU is where all the necessary calculations are performed for the computer to operate. Currently there are only really 2 major manufacturers of CPUs, AMD and Intel. The differences between the two are very few, but in general AMD CPUs are cheaper than their Intel counterparts. However, Intel CPUs tend to offer more value for money. Selecting a CPU is the second most important task when it comes to building a computer. The kind of CPU you can use is limited to what your motherboard can support, so you can't use an Intel CPU on an AMD motherboard and vice versa. But it's not quite clear cut as that, as each manufacturer has different models of their own processors, which have different socket and chipset configurations. The motherboard I have here supports an Intel LGA1150 socket type, so I've decided to use an Intel Core i5-4440 processor, which has a base clock speed of 3.1 GHz and most importantly is an LG1150 socket. When mounting a CPU in a motherboard, you must pay special attention to the orientation of the CPU within the socket. If you don't, then you'll likely break the processor if you try and mount it incorrectly. LGA1150 CPUs are fairly difficult to misalign due to the fact that these CPU sockets have special notches formed in them, so that the processor can only be seated in one orientation. Simply place the processor on the top of the socket, allowing it to locate itself in the socket. Do not apply pressure to the CPU. Locate the socket cover over the processor and gently but firmly locate the retention arm to hold the CPU in place. The next component we're going to fit is a stock heatsink and fan for the processor. Heatsinks are needed to prevent the CPU from burning itself out when you begin to use it, as processors can run up to incredibly high temperatures when left unchecked. One thing you must do before mounting a heatsink is to make sure that you have thermal paste applied to the processor. Thermal paste is applied to help move heat from the processor to the heatsink as efficiently as possible. You must be careful though. If you're using a new stock heatsink, thermal paste is most likely already applied to the underside of the heatsink. If paste is already applied to the heatsink, then you do not need to add any extra. If there isn't any, then you will need to add a small pea-sized amount to the top of the processor before mounting the heatsink. If there's slightly more processor area, then add a little bit more, but don't put too much on, as it can become very messy. To mount the heatsink on the motherboard, locate the heatsink over the top of the processor, lining each of the 4 posts up with the holes on the motherboard. Once this is done, press firmly but gently down on the opposite corners on the posts until you hear a click. Once you've done this, repeat the same process with the other 2. The fan on the heatsink plugs into the 4-pin connector on the motherboard labelled CPU_fan. RAM stands for Random Access Memory. RAM, if we're using the human body as an analogy, is where your short-term memory is, and is where you focus on tasks that are in hand. In a computer, the short-term memory is used to run programs and the operating system so that the processor has quick and easy access to them. The RAM is what is known as volatile memory, which means that when the PC is shut down, the files stored on the RAM are deleted. Like motherboards and CPUs, RAM comes in many different models and types, and you must make sure that the RAM you select is compatible with your system. RAM comes primarily in 4 different types relevant to the consumer: DDR, DDR2 and DDR3, and imaginatively DDR4. For your PC, you're not likely to need DDR RAM, as it's a very, very old standard and is pretty much extinct today. My motherboard supports DDR3 RAM, shown here on the motherboard. You can also find out what RAM your motherboard supports by looking at the documentation that came with it. Here I have a stick of DDR2 RAM and DDR3. Apart from the colour scheme and the heat spreaders, there are a couple of major differences. One being that the DDR3 RAM has a different slot layout to the DDR2 kind you can see here. This means that if you try and insert a DDR2 memory module into a DDR3 motherboard, you physically won't be able to. When choosing your RAM, there are a couple of other key factors you must consider: the speed of the RAM and the minimum amount of RAM required by your operating system. The speed of the RAM is a physical speed your CPU can access the memory. For example, these RAM sticks here run at 1866 MHz. Now, a common misconception with RAM is that if you have different RAM sticks, each with different speeds, say one runs at 800 MHz and the other one runs at 2400 MHz, each stick will run at its full speed when in use. This is not the case, and doing such a thing can lead to a very unstable system. What actually happens is that the RAM will run at the speed of the slowest stick, so in this case 800 MHz. So you lose all the potential speed that you'll have with the 2400 stick. So it's best to buy sticks that have the same brand and the same speed, because even if you buy, say in this example, you buy 1200 MHz sticks, it'll actually be more stable than the configuration we just talked about. As well as matching RAM sticks and their speeds together, motherboards and CPUs support different RAM speeds as well. The motherboard and CPU I'm using support RAM speeds with up to 1600 MHz. So if I were to use 2400 MHz RAM, it would only work at 1600 MHz RAM due to this restriction. This particular speed limit is not as important as when you match sticks together, and often you tend to buy RAM which is slightly faster than the maximum supported speed by the motherboard and CPU, as the sticks tend to last longer when in use, as they're not being constantly maxed out when in use. The final factor to look at is the amount of RAM being installed. Like with other components, your choice depends on the intended use of the system. Because I'm going to be using this for gaming, I'm going to install 8 GB, as this is what many games require as a minimum to run. However, for most users, the best way to determine the amount of RAM they need is by looking at how much their operating system requires to run properly. I'm going to be installing Windows 10 Professional, which according to the documentation requires a minimum of 2 GB of RAM to function. This is all well and good, but bearing in mind that you're likely to be using the PC for other things as well, 2 GB will not be enough, because you'll be installing things like antivirus and other little programs which will run in the background and take RAM. So in that case, 4 GB will be the best starting place for you, as it doesn't even cost that much different. To install the RAM, you need to open the latches at the end of the RAM slots and insert the stick, being sure to line the notch in the slot with the corresponding notch on the RAM sticks. Press down firmly and you'll hear a click as each latch closes, indicating that each stick is installed correctly. The next component I'm going to fit are the front panel leads. These are used to connect the front panel here with your, where we got here we are, with the power and reset switch and the activity LED to the motherboard. The pinouts for the front panel connectors can often be found either written on the motherboard or written on the documentation that comes with your motherboard. This motherboard has the actual pinout written on the board, so all I need to do is follow that and everything should work fine. With the motherboard components dealt with, I'll talk you through the other components we've required for the PC before we start installing everything inside the case. So a fairly important component is the power supply, or PSU for short, which doesn't really require much explanation as to what it does. It powers the PC. The only thing you must be careful of is making sure that when you select a power supply, it can handle your system. You must make sure that the power supply can provide more power than the PC takes. Otherwise your machine will not function when you try and turn it on for the first time. I use a power supply calculator on the website newegg.com. Here you input all the parts that you use for your machine and it will tell you how much your machine will take. From there I was told that I would roughly need 400 watts to power my system, so I've selected a Corsair 500 watt power supply as this gives me a bit more growing room as well. Because I'm building a gaming PC, I'll also be installing a high performance graphics card. Normally the graphical output of the PC will be handled by the CPU and output through those three little ports on the back of the motherboard which you saw earlier. This has the benefit of needing fewer components, but the side effect is putting more load on the CPU, which can generally be avoided by installing a graphical processing unit, or GPU for short. A graphics card has a processor built in that will generate the graphical output of the PC. This frees up the CPU to perform other tasks. Graphics cards fit into the PCI X16 slot on the motherboard and can commonly be powered by a separate power supply lead, like this one. The final component of the PC is the hard drive, or HDD. This is the computer's long-term memory and where things like your documents and programs are saved. For this machine, I'm also installing what is known as an SSD, or solid-state drive, to store the operating system on, as this will increase the performance of the system, as SSDs have a much higher transfer rate than the common hard drive. In addition to the 64GB SSD, for the rest of my programs and files, I'll also be installing three 500GB hard drives into my machine, which is the maximum number supported by my case, which will give me a full 1500GB of potential storage, which is more than enough for my needs. So now everything is explained, it's time to eventually install the components in the case. So to install the components in the case, you'll only really need one tool, a screwdriver with a Phillips crosshead on it. Now, I'm actually going to be using a multi-bit screwdriver with an extension, so that when I reach a screw that's per se in a more awkward position, then I can just get at it more easily. Also, you'll need the screws that came with the case, which I've got in the pot. I'll also be using an optional anti-static tether. Tethers are used to help disperse the static electricity that you may have built up from touching other things around you. Static electricity can be very dangerous to motherboards and other components of the PC because the static electricity can short out components. What you need to do with the tether is wear it on your wrist or any part of your body and attach the other end of it to another metal object to earth yourself. Here I'll be wearing my tether on my ankle and attaching it to my desk. Firstly, I'm going to install the I/O shield in the back of the case where the motherboard ports exit the case. This helps protect against dust and other debris from getting inside the machine. Simply push on each of the four corners firmly and it will snap into place. Just be careful to make sure you get the orientation of the I/O shield correct with the way that your motherboard will sit in the case. Next, we're going to install a motherboard inside the case. Line the ports up on the back of the motherboard with the corresponding holes in the I/O shield. Then locate the screw hole in the centre of the motherboard over the top of the corresponding riser on the motherboard tray. Using these screws supplied with the case, secure the middle of the motherboard first and then move around the other holes radially so as to prevent the board from bending too much. Be careful, however, not to tighten the screws too much as you may damage the delicate circuitry around the screw holes. With the motherboard secure, I'm now going to plug in the fan connector for the case. You plug the fans into the port marked sys_fan. Here I'm having to use a splitter as my board only supports one case fan. I'm now going to install the power supply into the case. With this particular case, the power supply will be installed with the fan facing outwards from the case, as there is a small cutout in the side of my case to allow the fan to exhaust the air that way. Yours case may not have this feature, so fit the power supply with the orientation where the fan has as much room as possible. Simply slide the power supply into the case and secure using the 4 screws supplied. The connections from the power supply fit into 2 plugs on the motherboard. The larger of the 2, which consists of 24 pins, is for the power for the board and most of the components on the board. The other smaller one, which in this case is 8 pin, is for the power supply for the CPU only. Next, I'm going to fit the hard drives and the SSD into the system. This case uses dedicated carriers to mount the drives in the case without the need to screw them in. I'm going to use 3 black serial ATA leads and 1 red one. The red one will be connected to the SSD with the Windows installation on it. This is so that if I have to disconnect a drive, I know not to remove this lead, as this computer will not be able to run without it. The SATA leads plug into the back of the drives in a set orientation, along with the corresponding power leads from the power supply. The SATA data cables then plug into the motherboard here. The final component to install is a graphics card. On the back of the case, remove corresponding blanking plates that line up with where the graphics card will locate. Here I will need to remove 2. Then firmly locate the card in the PCI X16 slot on the motherboard. Then, if required, plug a corresponding power lead into the socket on the card. The final task is to test the computer. Here I'll be using 3 programs downloaded from the internet. I'll be using NovaBench, Cinebench, and then the inbuilt benchmarking tool of Dirt Rally 3. The whole reason to perform benchmarks is to test individual components of the computer. Using the game benchmark, I'll also be testing the system as a whole, which gives me a good idea as to how stable the system will be. Okay, so there we are. That's everything complete. Everything's inside the PC now, and it worked. So all I can do now is wish you luck with your PC building, and thank you very much for watching. Bye.